Hello, Mr. Tarrou. We just got done solving or working on a couple of polynomial inequalities, and today, or at least in this video, same day, we're working on solving rational inequalities. Almost exactly the same directions, except for this part right here. We're still going to get our rational equations or inequalities set equal to 0. We're going to determine the x-intercept by setting the numerator equal to 0. And this is the only step that would be required if you were solving for a rational function. But when it's an inequality, you have to do one more step and mark off where it's undefined. So we're going to set the numerator equal to 0, and those are going to be the x-intercepts. That's going to be where this rational function graph crosses the x-axis. And then we're also going to determine, by setting the denominator equal to 0, what makes the rational function undefined. And these two steps are going to give us our critical values that we put on the number line, and that will break up the number line into 2 or 3 or maybe even 4, probably not 2 intervals, but 3 or 4 intervals that we then have to go basically guess and check to see which of those intervals actually work to solve the inequality. So let's see what this looks like, shall we? So our first question is going to be 2x plus 4 over x minus 7 is greater than 0. Okay, so very basic rational function, just one fraction, equal to 0. And we're going to solve this by setting the top equal to 0, then the bottom equal to 0. So we have 2x plus 4 equals 0. That's 2x equals negative 4. And by dividing both sides by 2, we get that x is equal to negative 2. Now, it's not really equal to negative 2. This is a critical value. This isn't really a solution. This is a critical value you're going to mark on your number line. Then, and this graph, if you were to graph this, it would cross the x-axis at negative 2. The numerator equals 0. That means the entire fraction equals 0. That means y is equal to 0. And hence, you have an x-intercept. Now, the denominator also needs to be checked. We need to find out where this is undefined. So x minus 7 equals 0. So x equals 7. This is where this graph is undefined. Great. Well, now we're going to take these two values, place them on a number line, and then those two values, let's go ahead and do that instead of me just talking, goes negative 2, positive 7, and now I'm going to check a number because this is not an equation, it is an inequality. I need this fraction, this rational function to be greater than 0, so both basically how do you divide two numbers and get a number bigger than 0 or a positive answer? They both have to be positive or they both have to be negative, and that's what this number line is going to help us determine. And we're going to do that by checking something in this interval, let's say negative 3. We're going to check anything between negative 2 and 7. Of course, 0 is going to be the easiest one. And then we're going to check anything bigger than 7, 8, 10, 12, 100, who cares? But it's got to be bigger than 7, so I'm going to pick the lowest number I can and try and do this in my head. So we're going to check with these values, each of those three intervals, see which ones work. The ones that do work are going to be our solutions. They're going to be our inequalities, or our inequality answers to this inequality. Hope you got those steps down. So let's check negative 3. So 2 times negative 3 plus 4 over negative 3 minus 7. Is that going to give us an answer greater than 0? Well, that's negative 6 plus 4 over negative 10. And yes, when you divide a negative number, this will be negative 2 over negative 10. When you divide two negative numbers, you get a positive answer. So this interval worked. Nice. How'd you like that squeak? Okay, you might not be able to see the orange very well anyway. So let's try yellow. Now we're going to try 0. So we're going to have, again, these are the checks, trying to find out which of the intervals on the number line solve this inequality. So 2 times 0 plus 4 over 0 minus 7, is that greater than 0? Well, 0, 0, so we're going to have 4 over, oh my goodness, no, negative anything nothing negative is bigger than 0. The negative numbers are to the left of 0 on the number line. So this section, this interval, did not work. And then finally the last one, at 8, 2 times 8 plus 4 over 8 minus 7, is that greater than 0? Well, that's positive, and this is positive. It's going to be 16 and 4 is 20 over 8 minus 7, which is 1. And the last time I checked, 20 was bigger than 0. So the last interval works. Okay, so let's write our final answer to this inequality. Well, our final solution is x has to be less than negative 2 or bigger than 7. With interval notation, that would be negative infinity up to negative 2, or from 7 to positive infinity. From to the left of negative 2 going to negative infinity, right of 7 going to positive infinity. Awesome. That example is done. Hope you understand it. I want to twist it up just a tiny bit. What if it were greater than or equal to 0? Well then, all the steps are the same. Our critical values are going to be the same. But I have to change my answers just a tiny bit, because now 0 is accepted. So not only do I have to check my intervals, which of course are still going to be the same, but I also have to check the actual x-intercepts, because, well, with equals, can I use negative 2? Not just to the left of negative 2, but can I use negative 2? Well, as long as I don't make this original rational function undefined, I can use it. So negative 2, when plugged into here, is not going to cause this to be undefined. So x can be less than or equal to negative 2. And with any inequality interval notation, that's a square bracket. But can I use 7? Again, because this whole thing can be 0, so if I use the value of 7 itself, will that make this entire rational function equal to 0? Well, no. If I plug in 7, I'm going to do 7 minus 7, which is 0, which is undefined. So this half of the answer is still going to remain the same. So there is a little bit of a twist when you have that equal sign with the inequality. You also have to check the x-intercepts. Basically, you'll be able to use all the x-intercepts that don't make the denominator equal to 0. Woo! All right, let's go on to the next one. Woo! I love this stuff. Okie dokie. Get this erased on my old style chalkboards. And do one more example. X minus 1 over x plus 5 is less than or equal to 5. Now, remember the steps I just erased? We have to set the numerator and the denominator equal to 0. So if you're tempted to go, well, that's 5 over 1, let's cross multiply, you're going to get rid of some of your answers, because one of the steps of solving your rational inequalities is what makes it 0 and what makes it undefined. If you multiply the x plus 5 over to the other side, you lost the value that makes the rational function undefined. So don't do that. I know we don't like working with fractions, but you can't be tempted by that. So what we're going to do is subtract both sides by 5. And you can see I'm leaving a lot of space because we're going to have to put that over 1 and find a common denominator so that I have that one fraction on the left-hand side. So I'm going to multiply both the top and bottom by x plus 5. And we're going to have to make sure that you catch that negative, that's in front of the 5 and distribute it through the parentheses. So we're going to get x minus 1, negative 5 times x is negative 5x. Negative 5 times positive 5 is negative 25 over our common denominator now of x plus 5. Okay, that's going to clean up to be negative 4x, or like terms, negative 26 over x plus 5 is less than 0. So now we're kind of looking like that previous example, and we're going to set the numerator and denominator equal to 0. X-intercepts and what makes it undefined. So we have negative 4x minus 26 equals 0. That's going to be negative 4x equals 26. And when I divide by negative 4, I'm going to get x is equal to, let's see, negative 6.5. And then the denominator, x plus 5 equals 0. So x, another critical value is x is negative 5. Actually, x can't be negative 5 because that makes the original rational function undefined, but it's still a critical value we have to mark on the number line. So our number line is going to be split up with negative 5, negative 6.5, and what do we have to do? Yeah, check the intervals. So check this side, check this, and we're going to see which ones pass and fail. So going back to the original inequality, we're going to have, what's to the left of negative 6.5? How about negative 7? So negative 7 minus 1 over negative 7 plus 5. Is that less than or equal to 5? Well, that's negative 8 over negative 3 is less than or equal to 5. Two negatives cancel out. 8/3. 8 divided by 3, that's 2 2⅔. Well, yes, 2 2⅔ is less than 5, so this gets a big old check mark. Let's try a number that is between negative 6 and negative 5, like negative 6. So negative 6 minus 1, again, back to the original inequality, over negative 6 plus 5 is less than or equal to 5. That's negative 7 over negative 1. And last time I checked, 7 is bigger than 5, not less than 5. So this center section, what I just used was the 6. That did not work. And I have a feeling the last interval is going to work. So let's try, 0. That's easy. That 0 is bigger than negative 5. So 0 minus 1 over 0 plus 5 is less than or equal to 5. And the last time I looked, negative 1/5 was less than 5. Great. So we have small interval worked, the middle interval did not, and the one on the right worked. Woo! We are so close to the answer. So our final answer is, our final answer is, okay, x has to be less than or can be less than or equal to negative 6.5, or x has to be greater than, is it greater than or greater than and equal to? I can't plug in 5. So, down here I can't plug in 5. So, that's going to be greater than negative 5. Did I just say I couldn't divide by 5? I can't plug in negative 5 because negative 5 plus 5 is undefined. So I cannot use a value or say that a value is a solution if it makes the inequality undefined. Okay, so this is our answer. Don't forget, with that equal sign, you got to check the intervals and the x-intercepts. Just don't use the x-intercept that makes the inequality undefined. That, as interval notation, is negative infinity to negative 6.5 with the square bracket to take care of the equal sign, or greater than negative 5. So it goes from negative 5 to infinity and beyond. Awesome. All right. Woo! Done, baby. Go do your homework.